what if you could secure your FastMCP server with AWS Cognito Authentication using just environment variables and a single decorator? We'll show you the production-ready pattern for clean, maintainable authentication, where credentials stay out of your code and protected tools become as simple as adding @MCP tool. You'll see exactly how to extract user claims, enforce group-based access, and keep your server locked down with minimal boilerplate. From FastMCP, import FastMCP. From FastMCP server dependencies, import getAccessToken. Hash authentication is automatically configured from environment. MCP equals FastMCP. Name equals AWS Cognito Secured App. @MCP tool. Async def getAccessToken claims. Dict. Get the authenticated user's access token claims. Token equals getAccessToken. Return. Sub token claims get sub. Username token claims get username. Cogni groups token claims get cogni groups. This demonstrates the OAuth proxy pattern combined with declarative tool exposure. The code shows how enterprise authentication systems like AWS Cognito can integrate with RPC frameworks, where the framework handles the OAuth flow while your application logic remains cleanly separated. The distinctive aspect is how authentication becomes an infrastructure concern rather than application code. The pattern works by externalizing authentication to a dedicated provider layer. The FastMCP server delegates token validation and user claims extraction to the AWS Cognito provider, while your tools simply access the validated claims through dependency injection. This separation means your business logic never touches raw tokens or validation code, maintaining a clear boundary between security and functionality. This approach matters because it solves the common problem of authentication boilerplate in microservices. By handling JWT validation, token refresh, and user claims extraction automatically, you avoid writing repetitive security code in every endpoint. It's particularly valuable for enterprise applications needing SSO, role-based access, or compliance features, where you want security handled at the infrastructure level rather than sprinkled through your code base. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core framework class for building AI-integrated applications. It provides the decorator system, authentication handling, and tool registration needed to expose Python functions as AI-callable tools. From FastMCP server dependencies, import getAccessToken. This imports getAccessToken, a dependency injection helper that extracts the authenticated user's JWT from the current request context. It centralizes auth handling, preventing token parsing duplication across tools. Hash authentication is automatically configured from environment. MCP equals FastMCP. Name equals AWS Cognito Secured App. This initializes the FastMCP application with AWS Cognito Authentication automatically loaded from environment variables. The name parameter identifies this instance for logging and tool discovery. This is the standard entry point pattern for FastMCP applications, where authentication configuration is externalized for security and flexibility. @MCP tool. Async def getAccessToken claims. Dict. Get the authenticated user's access token claims. This decorator exposes the function as an AI-callable tool in FastMCP. The async definition and type hints automatically generate the tool's schema, while the docstring becomes the tool's description for AI models. Token equals getAccessToken. This retrieves the authenticated user's JWT access token from the current request context. FastMCP's dependency system handles the injection, ensuring the token is always available and validated before reaching this tool function.
Return.
This begins constructing the response dictionary that will be returned to the calling AI model. The structured format ensures consistent, predictable output for AI tool consumption, with explicit keys mapping to JWT claim values.
Sub. Token claims get sub.
This extracts the unique user identifier from the JWT claims. The sub claim is the standard O auth2 subject identifier, guaranteeing each user has a unique, stable reference across sessions.
Username. Token claims get username.
Extracts the authenticated user's username from the JWT claims. This is a standard O auth2 claim that uniquely identifies the user in a human-readable format, complementing the machine-oriented sub claim.
Cognito groups. Token claims get Cognito groups.
This handles the Cognito groups claim with a fallback empty list. AWS Cognito may omit the groups claim entirely for users without group memberships, so the get with default prevents key error while maintaining consistent return structure. This defensive pattern ensures the tool always returns a list, even when no groups exist. This closing brace terminates the dictionary definition, finalizing the structure of access token claims returned to the caller. It ensures the function returns a clean, predictable JSON serializable object containing only the specified user attributes, preventing accidental exposure of sensitive token data. AWS Cognito integration pattern. The FastMCP tool decorator transforms Python functions into secure, AI-callable endpoints, while AWS Cognito handles authentication through standard OAuth flows, with claims automatically injected into your tool's context. The GetAccess token claims pattern demonstrates how to access Cognito-specific claims, like user groups, without manual JWT parsing. This approach maintains clean separation between business logic and authentication concerns.
The tool that never asks for credentials becomes the gatekeeper of all identities.